Welcome back to Behind the Text Curtain. Today we dove into one of nature's most powerful phenomena, hurricanes. Recently, Hurricane Milton churned through the Gulf of Mexico, bringing intense winds, heavy rain, and dangerous storm surges along Florida's coast. But what made hurricanes like Milton so powerful? And how did we predict and track them? Let's pull back the tech curtain and find out. Hurricanes, also known as tropical cyclones, are massive storms that form over warm ocean waters. They need a few key ingredients: sea surface temperatures of at least 26 degrees Celsius or around 79 degrees Fahrenheit, plenty of moisture in the air, ups and low wind shear to allow the storm to develop. When these conditions align, a cluster of thunderstorms can grow into a tropical depression, then a tropical storm, and finally, a hurricane if the winds exceed 74 miles per hour. Hurricane Milton followed this exact process, rapidly strengthening over the warm waters of the Gulf of Mexico before reaching Florida's coast. Meteorologists call this rapid intensification, where a hurricane's wind speeds increase by at least 35 miles per hour within 24 hours. Let's break down a hurricane's anatomy. At the center, we have the eye, a calm, cloud-free area where the air sinks. Surrounding the eye is the eye wall, which contains the most powerful winds and the heaviest rains. And then, we have the spiral rain bands, which can stretch hundreds of miles out from the center, bringing rain and gusty winds. With Hurricane Milton, we saw a well-defined eye as it intensified into a Category 5 storm, with winds exceeding 180 miles per hour. Although it reached Florida as a Category 3, its eye wall caused severe damage along Florida's west coast, demonstrating why this part of the storm is often the most dangerous. To track hurricanes like Milton, meteorologists rely on a range of advanced tools. Let's start with satellites. These orbiting eyes in the sky, like the GOES satellites, provide a continuous view of the storm's development, tracking cloud movements and changes in temperature. Closer to the ground, Doppler radar systems help monitor rainfall rates and wind speeds. This technology has been crucial in tracking Hurricane Milton's approach, giving us a real-time look at the storm's structure as it nears landfall. Ever heard of the brave hurricane hunters? These aircraft fly directly into hurricanes, like they did with Milton, collecting data on wind speeds, pressure, and temperature. This data helps refine forecasts, making sure we know exactly how strong a storm like Milton is and where it's headed. Lastly, we have computer models, like the GFS and ECMWF, which simulate the hurricane's potential paths. These models are why you often see those spaghetti plots on the news, showing a range of possible tracks. For Hurricane Milton, they've helped predict a landfall near Tampa Bay, guiding evacuation orders and preparations. In recent years, AI and machine learning have become valuable tools in hurricane forecasting. By analyzing massive amounts of data, including past hurricane patterns and real-time measurements, AI can improve the accuracy of predictions. For Hurricane Milton, AI models help meteorologists refine their forecasts of the storm's intensity, providing more precise warnings for the residents of Florida. The warnings are crucial for saving lives. When Hurricane Milton began showing signs of rapid intensification, hurricane warnings and storm surge warnings were quickly issued. But what's the difference between a watch and a warning? A watch means conditions are possible, while a warning means they're expected within 36 hours. Milton's warnings gave residents time to prepare for evacuation or shelter in place. One of the biggest questions surrounding hurricanes today is how climate change is affecting them. Warmer ocean waters, like those in the Gulf of Mexico where Hurricane Milton gained strength, can fuel more intense storms. Some scientists suggest that we might see more storms like Milton that undergo rapid intensification, leading to stronger and wetter hurricanes overall. While it's not yet clear if climate change will mean more hurricanes overall, there's growing evidence that storms will become more intense, with higher wind speeds and increased rainfall. To understand how far we've come in forecasting, let's look back at some historic hurricanes like Katrina and Irma. Both caused immense damage, and the tools we use today have improved dramatically since then. With Hurricane Milton, these advancements meant better predictions and more targeted evacuation zones, reducing potential loss of life. Looking ahead, new technologies are on the horizon to make hurricane forecasting even better. Drones could soon collect data directly from the ocean's surface, providing insights that satellites and planes can't reach. And advancements in satellite technology will give us even sharper images of storms like Milton, helping meteorologists detect changes even earlier. Ever wonder how to read those hurricane maps you see on the news? Let's use Hurricane Milton as an example. The forecast cone shows the possible paths the storm could take, but remember, the impact often extends beyond this cone. And those spaghetti models? They show different paths predicted by various weather models, helping meteorologists assess uncertainties in the forecast. Hurricane Milton serves as a reminder of the power of nature and the importance of preparation and research. With the tools and technology we have today, we're better equipped than ever to face these storms. But as climate change continues to reshape our world, staying informed is more important than ever. Thanks for joining me on this deep dive into hurricane science. Don't forget to like, subscribe, and hit the bell for more tech and science insights right here on Behind the Tech Curtain.